Okay, so the next unit we're going to get into, we're going to spend a couple days on this, but it's called matrices. Now, matrices, it's going to be kind of weird. It's just a little bit different, and in all honesty, it's kind of something that you're probably not going to see a lot more of, kind of moving forward, unless you kind of take a career in math. But it's definitely part of our standards, and they are actually kind of cool if you get into upper level math and play around with them, but really what a matrix is, and I kind of have an example here. They come in all different different shapes and sizes and stuff, but really what a matrix is just kind of just an organization of numbers. If you get into a lot of computer software, if you're kind of interested in that kind of stuff, all of the stuff behind the computer screen that you see is organized in an arrangement of numbers called a matrix. So, a lot of computer programmers, definitely deal with this kind of definitely type of math here. So, what is a matrix? So, like I said, it's just kind of a collection of numbers here, and we see our first example here. We're just going to call this A. We'll call this matrix A. Usually when we represent a matrix, it's with a big capital letter. Sometimes you might see this in like a super bold coloring, but they typically use a bold capital letter here. So what I have here, this is a 2 by 3 matrix. Okay, so again, they come in different shapes and sizes, and you're going to see different examples here as we get going. This is just a random example. These numbers really don't mean anything right now. But how this is organized is the first number is the amount of rows. Okay, so the first number that you see listed in the matrix is a row, and rows are left and right. So how many numbers are arranged in the left and right? Think of a church pew, they're arranged in rows. So as you can see, we've got 2 rows here. We've got 2 arrangements of numbers that are listed from left to right. The other number that you see, okay, the 3 here, these are columns. Okay, these are columns, and these are the amount of numbers that are listed up and down. Okay, so as you can see, right, these numbers, right, 7 and 10, would be the first row. 4 and 11, column. This would be the first column. This would be the second column. This is the third column. Okay, so in this particular matrix, we have a 2 rows by 3 columns here. Okay, so this is how a matrix is, this is the formality, or this is the notation that you're going to see dealing with matrix, because one example that you may see is they could give you an arrangement of a matrix like this, and then you're going to see something like this. So they're going to ask you maybe A sub 21. And what that's asking for, okay, it wants to know, for matrix A, what number is in the second row, first column? Okay, so again, it's row by column, so 2, 1. The second row, so we're dealing with this bottom row here, and the first column, right? So it looks like it would be this number 10. Okay, so different matrices are going to be represented with different numbers. In this particular case, that 2, 1, right, it's row by column. So maybe they say, what is I don't know, 54. So what that's asking for is what number is represented in matrix A in the 5th row in the 4th column. Well, notice we only had a matrix that had 2 rows, right? So the 5th row would be like 3, 4, 5. Well, there's no number there, so this is undefined. Our matrix doesn't exist that far out, okay? Our matrix is only a 2 by 3. Okay, so just kind of getting used to this first video that you're going to see is just kind of getting you used to the terminology and some of the notation, playing around with the numbers. Once you really get the hang of these things, they're super easy to kind of manipulate. They're just kind of weird to see at the beginning. Okay, so let's look at our second example here, right? We've got matrix B. Okay, well, matrix B, can you see how many rows does matrix B have? Well, you can see from left to right, we only have 1 row here. So this would be a 1 by, well, how many columns are there? So how many things are there up and down? right? So we got 1 column, 2 column, 3 column, and our 4th column. So this matrix would be a 1 by 4 matrix. And lastly, letter C here. Again, you know, how are the numbers arranged? Row by column. Well, you should be able to see I have 1 row, 2 row, 3 rows. So this would be a 3 by, and how many columns do we see? Well, there is only one arrangement of values going down. So that would be a 3 by 1 column here. Okay, and again, you know, just kind of get you used to the terminology, getting you used to, you know, how these numbers are represented. So we're going to look at a couple operations with this. Now that you, like I said, maybe just kind of seeing it right away might distract you, but, you know, once you see it for the first time, it really isn't that bad to get the hang of here. So the first, or the only operation I'm going to show you on this video is, I think, is the easiest. Okay, so we're going to look at a scalar multiplier. You know, you've maybe heard of a scalar. You know, a scalar kind of bumps something up to the next level. So when we're talking about multiplication here, operations for a matrix has a scalar multiplier. Okay, so I've got two different examples here. I've got matrix A and I have matrix B. Okay, so if we're, you know, talking about what we just discussed, this is a 2 by 2 matrix. Kind of get used to a 2 by 2. This is the traditional form that you're going to see a lot, just for the basic understanding that we're dealing with. But the reason I have this set up is because you may see something like this. So you may see an matrix A here, and they're going to ask you this. You know, what does 2A equal? Okay, well, you know, it's still an operation. It's, you know, it's not anything different from what we've seen before in math. This is still 2 times A. So what it's asking you, it wants matrix A on a scalar of 2. So literally all we're going to do is every number we see inside here, we're going to multiply by 2. Okay, so again, it wants a scalar of 2. You know, we're multiplying 2 times A. So we're going to take every number that we see inside that matrix, and we're going to multiply it by 2. So the first row, first column there, we see is 7. 7 times 2 is 14. First row, second column, we have 10 times 2, which is 20. Second row, first column, we have negative 1 times 2, which is negative 2. And second row, second column, we have negative 8 times 2, which is negative 16. So here would be my new matrix. Okay, so again, nothing too, I don't think it's too difficult there, just something you got to kind of get used to seeing here. So we're going to do one more example here. So now we have matrix B. Okay, so we should observe that matrix B is also a 2 row by 2 column matrix, right? We have a 2 by 2 matrix. I don't know, let's look at an example. Say they want, well, what is negative 3b? Okay, so if you see this, we have the matrix B, and the question's asking you what is negative 3b. So literally all that's asking you to do is every number that you see hanging out in your matrix there, we need to multiply by a negative 3. Okay, so then off to the side, I'm going to multiply all those numbers by my negative 3. So negative 5 times negative 3 is a positive 15. 0 times negative 3 is a 0. Negative 4 times negative 3 is a positive 12. 12 times negative 3 is a negative 36. Okay, so here would be that new matrix B to a scalar of a negative 3. Notice how the shape, right? The shape of the matrix didn't change. You know, we have a 2 by 2 matrix. When we multiplied by that scalar, it stayed a 2 by 2 matrix, right? Our 2 by 2 matrix here stayed a 2 by 2 matrix. Okay, so I know I went through that pretty quick, but hopefully we kind of got the hang of it there. Just kind of getting you used to the notation, getting you used to seeing the scalar. I'm done with this video. The next video that you're going to see me post is we're going to get into some adding and subtracting here.